When working with minimal APIs, you need to organize your endpoints and not keeping all the endpoints registration inside program.cs. In this video, I'm going to show you how we can use source generator instead of reflection to organize your endpoints by doing something very interesting and cool. So let's jump into the code. I have here a new web API project. It is brand new. There is no endpoints configured. I only added Swagger just to see the endpoints. So if I run it, there is no endpoints defined. And basically what you do is start adding endpoints. And one way to do that is adding endpoints inside program.cs. I don't like that approach because it is not organized and all of my code will be inside the program.cs. You can do something like map get here and start adding your pattern, and you can inject services and so on. But I don't like that. What I usually do is I can create a folder here. Let's call it endpoints. Inside the folder, I can have an interface, endpoint. This interface will contain, it's an interface. This interface will contain one method, which is void map endpoints. And we can pass by the endpoint route builder. Let's call it endpoints here. And then if I need to have a new endpoint group for a user, let's say, I can create a user endpoint here. And we can implement the endpoint interface, endpoint interface. Once we implement, we can here have something like endpoints.mapGet. Can specify the pattern and maybe return something like list of users. Maybe another endpoint for creating a user. You can here inject a model or something, but for this demo, it doesn't matter. So results.ok, user created. And then you go to your program.cs and you do something like this. New user endpoints dot map endpoints, and you pass the app. I know what you are going to say here. Yes, you can create a static class. Inside of it's an extension method, map user endpoints, and then in your program.cs, you can do something like app.map user endpoints. But what I don't like about that approach, you will have a lot of static classes with a lot of extension methods, and there is no way to automate that flow. But when dealing with an interface, you can make sure that all of your endpoints will contain the same definition, and you can organize all of your endpoints within the same definition. In that case, it's map endpoints. So here, if I need to add another endpoint, I need to create it and then go to the program.cs and do the same thing over and over again. But we can use source generator now to actually generate that code for us and make our life very easy. So I'm gonna start showing you how I can use source generator. The first thing that you need to do is creating a new project. It should be a class library. Let's call it source generator. Yeah, source generator. We are going to change the SDK from here. Basically, let me delete the class, edit the CS brush file, change it to net standard. It has to be net standard in order to work. And the first thing you need to add, let's also, before that, let's update the language version to latest. The first thing we need to add is, let's manage NuGet packages, and we need a couple of NuGet packages to install. The first one is microsoft.codeanalysis.analyzer. Analyzers, let's install that. And the other one is microsoft.codeanalysis.c#. So let's add that as well. Once added, you can start by creating your first generator class, which is endpoints generator. Okay, now start by adding the generator attribute here, and you will notice a warning here saying that, hey, you need to enforce the extended analyzer rule. So let's go to the CS approach and do that exactly. So true, build, and now the warning is gone. What we need to start with is to implement the I incremental generator. So if you have some experience working with source generator in the past, you will implement the I source generator class, but recently Microsoft is pushing to use the I incremental generator, which is more powerful than before, and it is very easy to use for the IDE as well. So I incremental generator, it has only one method, which is initialize, and you can start building your code in here. Let's make it bigger. Okay. So I'm not an expert in source generator per se, but I know what to apply to use it for my needs, and basically doing that refactor inside the code without dealing with reflection. So the first thing that we need is to create a provider that is basically representing all the syntax. Syntax is basically whenever the user is typing something inside the IDE, we are going to catch it. But we are not going to catch everything. We need to catch only the syntax that are related to a class. So can start by creating a provider, which is context.syntaxProvider.createSyntaxProvider. And we need here to pass by and provide few arguments in order to generate it with syntax that are related to a class. To do that, first for our predicate, we need to check for all the syntax nodes that are basically a class, and we can do it by doing something like this. So node is class declaration syntax. Okay, let's do something here. Yeah, come. This is for the predicate. For the transform, we need to, and if you check here, I don't care about the token. So we need to, the node that is being returned from the predicate, I need it to be cast as class declaration syntax. And basically we can do something like this. Cast the syntax context.node. And then it's better to make sure that we are not returning any null. Okay? Now we have a provider. The next step is to compile whatever we are collecting from the provider into a compilation object that we can use for the transform, for the generation part. And we can do something like this. var compilation equal context dot compilation provider dot combine, and we pass it the provider dot collect. So we have now a compilation object, and then we can do something like context dot register source output compilation, and this is the method that we are going to use. I'm gonna call it execute and generate it as a separate method here. So let's change few of the argument name here. So arg1 will be context, left we can name it compilation, the immutable array of class declaration syntax. This is our classes basically, and args2 can be the tuple. And then let me first break down the tuple into two different variables. So var compilation classes equal the tuple. Okay. Now let's try something small. Let's try to generate a class, an empty class, without thinking about the endpoint for now. So to do that, let's create a new string, var code equal. I'm using the literal string. If you don't know that, this is basically will help me write a code without dealing with all the backslash and things. So our class, I'm gonna first add an attribute auto-generated, just to name it and be consistent with any generated classes out there. It will have a namespace of minimal APIs, I think. Minimal APIs, yeah. This is a namespace, and I'm going to create a static class, and we can call it Endpoints extension. This is our class. Let's add a tab, and then here we can have a static method, public static endpoint route builder, map all endpoints, and this is an extension. So this endpoint route builder endpoints, and here here we can return endpoints for now. And now this is our code. We can use the context to actually add source and return that and generate that file. Basically, hint name is the file name. So I can call it the same name of the class, endpoints extension dot g as generated. This is a common use for generated classes, .cs. And we can specify the code that we are going to use. And that's it. So theoretically speaking, we are going to generate a new class, endpoints extension, that contain one extension method, map all endpoints. So to use it, let's go back to our minimal APIs project here and manage references and add the source generator reference here. So once added, let's go back and edit the CS proj because we need to change something here, which is in order to make it work, we need our output type to be analyzer. Basically, you don't need to do that when you pack it as a NuGet package. It will be done inside that NuGet package. But for our testing purposes, we need to add that here. So now, if I go to my program.cs, I can do something here, map all endpoints. Still not found, but once I build my project, doesn't contain, but map all endpoints, we need to import the namespace, which is minimal APIs here. And you will notice it is here. And yeah, it is our definition. We can go to the implementation. You can see this is exactly what we created. The namespace, the class, and the method here. Perfect. Now, let's do some magic and start injecting our interfaces and our basically endpoints per interface. Go back here and let's close this one. What we need to do is let's first break this code into two different codes, which is the first one is prefix code, and I'm going to create a suffix code as well. So the suffix code will contain all of that. And the prefix code will contain this one. And then I'm going to create a string builder, code builder. We will add prefix, append line, prefix code, and then the last line should be code builder dot append the suffix code. And here we can do code builder dot toString. This is the same thing that we added, but here we can start injecting our code inside of that. Basically, we need to loop through the classes that we have to check if the class implement an interface called iEndpoint. If true, we need to generate the code for that class. So basically, for each classes syntax, we need to check if the syntax contains implement the interface. First, we need to create a symbol from that syntax. So compilation dot get semantic model syntax dot syntax tree dot get declared symbol syntax I named type symbol. Now created the symbol, we can do something like this. So symbol dot all interfaces dot any. So that's I dot name equal to I endpoint. So basically we need not. So if we have an interface that is named I endpoint, we need that. If not, let's continue. So always fails first. Always try to do your guard check first and then resume with your operation. So here, our symbol, our syntax, our class implement the I endpoint. We can do something like this. Code builder dot append line. Let's add few tabs here to make it consistent. And we can do something like new symbol dot name dot map endpoints. And now each time we have a class that implement the I endpoint interface, we are going to have this line added to the code generated class. Let's build everything. User endpoint cannot be found. This is an error, a build time error inside our source generator code, because the user endpoints class, we don't have a reference for it. So we need to change our prefix code here to using minimal APIs.endpoints. Save. Let's rebuild. There is no argument given for the corresponding endpoints. Shoot. So here we need to pass by the endpoints. So basically map endpoints needs the argument endpoints here. Let's rebuild. So what's happened here is a very good example why you should use a source generator instead of a reflection, because out of the box, while doing the development, you will be able to see the errors. In reflection, you need to run your project and start screaming, basically. So now we build our code. Let's go back here. If we view the source, you can see we have new user endpoint, map endpoints, and we are returning things here. So basically we can delete this one. Let's run the project. We have our endpoints here. But now, if we go to endpoints and we can create a new class, let's stop it. Create a new class here. Let's name it organization endpoints, let's say. And we can implement the I endpoint. The I endpoint interface. Once we implement that, we can here do the same thing that we did before. Endpoints dot map, let's say, put organization and something else like whatever. Hi. And you will notice now, let's build. Notice we have an organization. Basically, you don't need to build because our endpoint generator is working on incremental generator. So basically, whenever you type, and that was, if you stop it, let's add a quick one here. Let's add product endpoints. Same thing, endpoint, save, and here endpoints.map post products results.ok. Save. If I run it, I will see it directly without actually doing a rebuild for my solution. And that is basically awesome. And if you stop, you can go back. Now, if you don't see it, basically we are not seeing it. It's an old generated file and it's cached by the IDE. Basically do a quick clean. If you clean everything, you'll notice we're going to have a build error here once we clean. And then you can do a rebuild for the solution. It will succeed again. And you can view the source. And yeah, we have all the generated classes here. And basically, if you go now to each of your endpoints, you will see it is being used by the endpoint extension generated class. And that's it for me, guys. This is how you can use the source generator in an easy way to organize your minimal APIs. Let me know in the comment below, how are you going to use the source generator? And if you are using source generator, what are you using it for? Make sure to keep a like and subscribe. And I will catch you in the next one. Bye.